So looking at estimating quotients, we are looking for compatible numbers to make it easier to divide, right? We already know that division is taking a whole and separating it into parts or groups. You're correct, parts or groups. And this is just a quick and easy step when we don't need an exact number. So anytime we see about how much or about how many or just the word estimate, we can use rounding and or compatible numbers, okay? So in the directions, it says in 1 through 8, you're going to estimate using compatible numbers. And as we just saw in the video, compatible numbers make it easier to divide. So if you're looking at 287 and 42, think about the factors of this first digit, right? If we're thinking about the factors of this first digit, what is a factor of 4 that might make 287 more compatible?
8.
No? Yes? Yes? Let me change my question. 4 is a factor of what number? Trista? Look at the numbers that we're given here. 28.
Oh.
28.
I see. So,
Does everybody see that? So we have 4 and we have 28. So what would our compatible numbers be? 280. And what? And 40. How many times will 4 go into 28?
what?
How many times will 4 go into 28?
7.
7 times. So reasonably, we could say that 287 divided by 42 is about 7, right? How do we check that for reasonableness?
Do it the other way around.
Okay, we're going to flip this problem, and we're going to multiply what? 40 times 7. Excellent. Make sure you're getting this on your paper. So we know that 7 times 0 is what? 0. And 7 times 4 is?
28.
28. So are we close? Yes. Right on the money, right? Okay, so let's look at 320 and 11. 320 and 11. What would good compatible numbers be?
1 and 32.
Okay, 1 would take us too low, right? 32 is really a good number. But don't we already have a 0 at the back end?
Yeah.
Yes. So do we want to change 320, Joseph? No, we don't want to change 320. So what's going to be a compatible number to go into 320? Austin?
32.
No, we've already changed this to 320, or kept this. What are we going to do with this one?
Oh.
Yes, ma'am.
Make it to a 10?
Make it a 10.
That's what I was going to say.
Make it a 10. So we learned in estimating products that all these back end zeros make multiplication so much easier, right? So if we're taking 320 and we're dividing it into 10 groups, how much will we have in each group?
Oh. Well, in each group there'd be 10, right?
We're going to put it into 10 groups. So how many in each group? Very good. 32. How do we check for reasonableness? Multiply. So we're going to take 32 times 10. We learned from estimating products that this 0 can just be brought down into our product. And then we have 32 times 1, which is 32. And we are correct. Okay? Let's try another one. We're catching on. We have 208 divided by 72. 208 divided by 72. A little bit trickier number to work with. Joseph. Okay? We could go with 200, right? Is 200 going to be real easy to get into 72? Or to divide by 72? Kelsey? 210, right? That's got a back end 0 as well, but it's a lot closer to the number 208. Everybody understand that?
So if we turn the 208 to a 200 and then we turn the 72 into a 70.
Okay, the 70 is right on the money. But this one that Kelsey gave us is a lot closer, right? Does anybody see something familiar in those numbers? Austin?
Yeah,
We're in this one, baby. Okay, Joseph? Already said that. Will?
that 7 times 3 is 21.
Absolutely. 7 is a factor of 21. So if 7 times 3 is 21, 210 divided by 70 is what?
21. Oh, sorry. 3.
Very good. 3. How do we check that?
70 times 3.
70 times 3. 3 times 0. 3 times 7.
21.
21. And we have a match. All right, one more. 554 divided by 62. What would make those compatible and easy to divide? Morgan?
You turn 554 into a 550 and 62 into a 60.
Okay. How easy is 6 to get into 55? Is it an equal factor? No. So I like the 62, but and changing that to a 60, but 550 would give us a remainder, like Will just said.
Yeah.
So let's think of our rounding rules. What would this 5 tell us to do to this 5?
Go up.
Go up. So what is this number going to change to? 600. Does that look a little easier to divide?
Yes.
How many times will 6 go into 60? 10 times. How do we check that? How about multiplied by? Okay. So how many zeros do we have at the back end? 2. We have 1 here and 1 here, so those go into our product. And 6 times 1 is 6.
6 600.
All right, does that make sense?